If you remember, in part 1 we successfully deployed Cloud APIC on AWS. You can always verify or adjust your settings by clicking on the Intent button and selecting the Cloud APIC Setup option. Let's now configure the logical network just as we know it. Our objective is to provide connectivity between web and database server instances, both running on AWS, and also to provide access from the internet to the web server through SSH. In order to accomplish this, we will follow our 5 well-known steps, and we will start by creating a tenant. Since each tenant we create in Cloud APIC on AWS will require a different AWS account, Cloud APIC will need to have enough privileges over such tenant accounts in order to automatically configure their network. Therefore, before we get started with the configuration, we will need to run the tenant CloudFormation template. Simply go to your AWS console on your infra account and click on the S3 service. You will see some Cloud ACI S3 buckets, which were automatically created as part of the installation process. Click on the one that includes the word common, and you should see the tenant CloudFormation template as a JSON file. Download it, and now on the tenant account, open CloudFormation, click on Create a Stack, and simply upload that file. Click Next, add a name to it, and accept the terms. That's it. Cloud APIC is now ready to automate the network configuration for this tenant. We can now proceed with our configuration. First, we will create our tenant with its VRF. Then, we'll associate it with a cloud context specifying US East as its region. We will include 192.168.0.0/16 as our main CIDR block, and we will be creating 2 subnets from it, .100 for Availability Zone 1A, and .200, which will be associated to Availability Zone 1B. And finally, we will choose Transit Gateway as the connectivity method for this VRF's cloud context. Are you ready? Let's jump into Cloud APIC then. On the left menu, go to Application Management, Tenants, and click on Create a New Tenant. You will always find a tutorial for every step we take in Cloud APIC. Feel free to read through. However, we will simply close it for now. I'll add a name for my tenant, and I will provide a tenant's AWS account ID right here. You can find such value in your tenant's account on the AWS console if you click on My Account. That's it. Now, Cloud APIC wants us to create the VRF as the next step. So, let's do it. I will simply add a name to it and we're done. Now, the next step is to create a cloud context for our VRF. So, let's do it. I'll add a name to it, and as you can see, my tenant is already associated. So, I'll go ahead and select the region I want this context for, in our case US East 1. I will add my main CIDR block, which in this case will be 192.168.0.0/16, and then I'll create the 2 subnets, .100 for Availability Zone 1A and .200 for Availability Zone 1B. I will also mark this CIDR block as my primary one. Finally, I will enable this VRF's context to connect to other VRFs through a Transit Gateway attachment, selecting the hub network we created in the initial setup wizard and associating it to the 2 subnets I just created to have availability zone redundancy. And we're done. Let's now take a look at what was automatically created on the tenant account by logging into its AWS console. First, we can see that a VPC was automatically created for this tenant account, including its CIDR block, subnets, and routing tables for both ingress and egress traffic. Both subnets have already been associated to the corresponding routing tables, and an internet gateway has also been created for this tenant. Then, if we go to the Transit Gateway section, we can see there are already a couple of them. Now, if we compare the Transit Gateway IDs with the ones on the infra account, we can see that they are the same, confirming that Cloud APIC runs the Transit Gateways on the infra account only, and then that it automates sharing those resources with each tenant account as they need it. As you would expect, we can also see that 2 Transit Gateway attachments have been created as part of the automated process as well. The next step, as we know it, is to create an application profile. You simply have to go to your Cloud APIC, click on Application Profile, and create a new application profile for your tenant. We're now done with step 2. Moving on to step 3, we now need to create our EPGs. As covered before, EPGs in Cloud APIC are always microsegmented, meaning that we need to define a selector to match specific attributes in order to let Cloud APIC automatically assign the EPGs to each instance in the cloud or prefix. Remember, there is no need to define bridge domains in Cloud ACI. In our case, we will create a couple of EPGs. One called web, which will include a selector matching US East 1 region and a tag specifying that the owner is Carlos. This means that any instance we create that matches that specified criteria will automatically be mapped to the web EPG. We will also create a database EPG, which will use a similar selector, but mapping it this time to a different tag value, matching the DBA as owner in this case. Let's now go ahead and create such configurations on Cloud APIC. In the Application Management section, click on EPGs. We'll create our first EPG, which we will call Web. We'll select our tenant, application profile, and our VRF, and we will assign a selector as mentioned before, matching the US East 1 region plus the owner tag with my name on it, which is Carlos. We'll do the same for the database EPG now. This time with the tag matching the DBA as owner, and that's it. We're pretty much done. If we take a look at the Tenants AWS console now, you will see that a security group was automatically created corresponding to each EPG. We will skip the contract part for now, and we will create our external EPG representing the internet, since we want to have access to the web servers directly from my laptop. Just like on-prem, remember that in Cloud ACI, we need to classify external EPGs with selectors as well. So, we will create our internet external EPG with a selector matching 0000/0 for such purpose. Let's go ahead and do it now. In the EPG section, we'll click on Create EPG again. We'll call this one Internet, associate it to your tenant and application profile, and this time we will set the EPG type to external. We will choose our VRF and create our selector with a quad 0 value as mentioned before. And we're done. Let's now launch a couple of new instances on the AWS tenant account. As you can see, we have nothing running at this point so far. I will create my first instance choosing an AWS Linux image with a T2 micro size. And then I will configure the instance details. If you click on the networking section, you should be able to see the VRF we just created from Cloud APIC as part of the options. Let's select it, and then in the subnet section, you should also see both subnets from the Cloud Context Configuration section. If you do not see your configuration from Cloud APIC at this point, it means that you have missed running the tenant CloudFormation template. So make sure you do that. I will choose one of these subnets now, and since I will use this instance as a web server, and I will want to access it through SSH from the internet, I will enable it with a public IP address as well. I'll then go ahead and click Next, and I will add a tag saying that the owner of this instance is Carlos. That way, whenever the instance is running, ACI will automatically match it with the selector I created before for the web EPG. I'll click on Launch, selecting my existing keeper for SSH access. While we wait for it to be ready, let's create a database instance now. The main difference is that I will not request a public IP address for my database server, since I don't want it to be visible to the internet, and I will set the owner tag value to DBA. After a few seconds, both instances are up and running, one with a public IP and the other one without it as expected. If we take a look at the web server instance, you can see that it automatically got its security group based on the EPG selector we defined, and the same happened for the database instance as well. So I would like to ask you, since the web server has a public IP, will I be able to SSH to the web server directly from my computer? Let's give it a shot. I'll click on my web server instance and I'll try to connect to it through the embedded AWS client this time. As you can see, the interface hangs. We're getting no reply. Let's now try it through my computer's terminal. I'll copy and paste the provided command, and well, same thing happens. No response. Why is this happening? Well, because as you may remember, different EPGs do not have communication by default, and we are trying to connect from the Internet external EPG to the web server EPG without a contract. Same ACI rules as on-prem, remember? We can confirm that no inbound rules have been defined on the AWS console by going to the web server security group And as you can see, inbound communication is only allowed if it comes from the same EPG, just like you know it. Let's fix that now by creating a contract. In this case, we will want to allow all traffic coming from the internet to access our web server instance. Therefore, the consumer will be the internet and the provider will be the web EPG. And this configuration should result in automating the right security group rules on AWS. In your Cloud APIC, go to the contract section where we will create a new contract called Internet. We will select our tenant, we'll keep the scope as it is, and we'll add the default filter which allows all traffic. Let's now apply our contract. On your top right, click on the Intent button where the top used tasks appear, and click on EPG Communication. Let's select our contract called Internet. And then let's place the Internet EPG as the consumer and the Web EPG as the provider. Click on Save and let's go back to the AWS console and try to connect to the web server again. As you can see, we now have access both through the embedded client and through our terminal as well. If we now take another look at the web server security group, we can also see that Cloud APIC automatically modified the security group rules per our contract definition. However, the second question would be, will the web server be able to ping the database server? Let's try it. As we can see, the database server's private IP is 192.168.200.186. So let's open a console on the web server and try to ping it. As expected, it does not work, since there is no contract between the web and the database EPG yet. As you may remember, we only want to allow ICMP traffic between both EPGs and HTTP traffic from the database EPG to the web EPG per our initial objective. So we will create a new contract between them to finalize our configuration. Let's go back to our Cloud APIC and let's go to the contract section, create a contract, add a name to it, associate it to your tenant, and we will add ICMP as filter, and we will also add the HTTP filter so that it is also part of our contract. Let's now go back to the EPG communication section and choose our contract from the previous screen, specifying the web EPG as consumer and the database EPG as provider. Let's try that ping from the web server again, and it works as expected. If you want to verify your configuration in Cloud APIC, you can always go to the topology section where you can see your tenants, VRFs, EPGs, contracts, and if we click on an EPG to maximize its related information, we can also see the cloud instances correctly associated to it. It all seems to be working fine now, and our objective has been met for a single tenant and VPC in a single region. However, you may be wondering what changes if I have to communicate multiple tenants, regions, or VPCs. Well, the great news is that it all stays pretty much the same. You just have to account for different site blocks and subnets for each VRFs or tenant and define contracts that have a tenant or global scope depending on your need. If you need a single tenant and multiple VRFs, a tenant scoped contract should do. However, if you want to communicate different tenants, just build your contract in the common tenant and define its scope to be global. The rest stays pretty much the same and will also be fully automated for you. As a summary, we just learned how to deploy Cloud APIC and provided connectivity to instances running on AWS in one VPC and region or multiple, defining our configuration once and keeping it consistent anywhere. We are still using AWS Cloud Native constructs as you saw, and everything ACI automates is visible on AWS console as well. This can help you reducing the learning curve and accelerating your cloud migration or integration through ACI's automation capabilities, normalizing your cloud experience through a single security and visibility model across regions and clouds.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.